This is Dr. P. Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about our definitions and terminology. So, Module 3 I am discussing here. So, our Module 3 name is Correlation and Regression. So, in correlation and regression, contents, definitions and terminology, question bank of correlation and regression. So this is our third module. In third module, we have the topics are here. In correlation, correlation coefficient is there. First topic is correlation coefficient, and second topic is rank correlation coefficient, and next equal or repeated ranks, equal or repeated ranks for the rank correlation coefficient. So this is our correlation coefficient, and coming to this is correlation, first chapter, and the second chapter is based on regression. So in regression we have a method of least square is there. Two methods are there. Regression lines, method of least squares, and actual means. So one more method is there. So that is based on actual means, expected actual means, and these are both are based on lines of regression or regression lines. Okay. So that is our regression. So total we have 5 topics are there in definitions and terminology. First question is, describe the Carl-Pearson's coefficient of correlation. Describe the Carl-Pearson's coefficient of correlation. So it is a method to find the strength relationship between two variables. What is correlation coefficient? It is a method to find the strength relationship between two variables. It is denoted with R. So where R equal to sigma capital XY by and the root of summation x square into summation y square, and where capital X equal to x minus x bar and capital Y equal to y minus y bar, and x bar equal to summation xi by n and y bar equal to summation yi by n. Okay, so this is our Carl-Pearson's coefficient of correlation or correlation coefficient. Next definition. State the simple correlation. So what is correlation? First of all, the correlation is the relationship between the two variables is known as correlation. In that we have two methods. First one is simple correlation and second one is multiple correlation. So in correlation, the correlation is nothing but the relationship between the two variables is known as correlation. In correlation, we have two methods. First one is simple correlation and second one is multiple correlation. In simple correlation, the relationship between only two variables. So what is simple correlation? If the relation between two variables is known as simple correlation. For example, y equal to x square. So this here, x comma y are two variables. X comma y are two variables. The relationship between only two variables is known as simple correlation. So here, this is the example, x equal to y square or y equal to x square. These are the examples for simple correlation. Next, explain repeated ranks of rank correlation. If there are more items with same values, then the common ranks are given to repeated items. This common rank is the average of ranks. This common rank is the average of ranks which items would have assumed. So therefore, the correlation coefficient, the repeated ranks of rank correlation coefficient is rho equal to 1 minus 6 into sigma d square plus 1 by 12 m cube minus m plus 1 by 12 m cube minus m plus and so on divided by n into n square minus 1. So this is our rank correlation coefficient for repeated ranks or equal ranks. Okay. So if we have, for example, if I am here I am having the marks for X are some 20, 40, 60, 40. So here I am giving the first rank for highest mark. So this is first rank. Actually this is second rank and this is third rank, right? So but here we have same marks. So that's why I am taking 2 plus 3 by 2. I am taking the average of these two ranks. Okay. So that is 2 plus 3 by 2. That is nothing but 2.5. So here I am giving 2.5 and here also I am giving 2.5. So for 40, here I am giving 2.5 and here also we are having 40 now. So that's why I am giving 2.5. And the next rank goes to 4 only. Because already second one and third one is over. We have taken the average of those two ranks and here we are keeping 2.5 and 2.5. So this is our repeated ranks or equal ranks in rank correlation coefficient. The formula is rank correlation coefficient is denoted with the rho equal to 1 minus 6 sigma d square plus 1 by 12 m cube minus m plus 1 by 12 m cube minus m plus and so on divided by n into n square minus 1. Here m is nothing but how times the rank is repeating. How many times the rank is repeating. Here it is repeating 2 times. So that's why we have to take m equal to 2. So that is the formula for repeated ranks of rank correlation coefficient. Next question. Explain the correlation. The degrees of the relation, between the variables is known as correlation. The degree of the relation between the variables is known as correlation. Or the relationship between two variables. Simply we can say that what is correlation? The relationship between two variables is known as correlation. Next one. Narrate the properties for correlation. So the correlation coefficient is always lies between minus 1 and 1. The correlation coefficient is always lies between minus 1 and 1. So this is the property for correlation coefficient. So minus 1. So always the correlation coefficient is denoted with r, small r. So that's why the small r is always lies between minus 1 and 1. Small r, the correlation coefficient or coefficient of correlation is always lies between minus 1 and 1. So if r equal to 1, then the relation is perfect and positive. If r equal to minus 1, then the relation is perfect and negative. If r equal to 0, then there is no relation between the variables or then there is no relation between the elements. So those are the properties for correlation coefficient. Next, sixth one. Describe the rank correlation. Describe the rank correlation or rank correlation coefficient. So it is also used to find the strength relationship between two variables. Okay, so it is also used to find the strength relationship between two variables, but it is rank correlation coefficient, no. So here we have to find by using ranks. It is also the strength relationship between the two variables by ranks. So that is called as rank correlation coefficient and it is denoted with rho. So where rho equal to 1 minus 6 sigma d square divided by n into n square minus 1. So this is our rank correlation coefficient. Next definition. Narrate the properties for rank correlation coefficient. So the rank correlation coefficient is the rank correlation rank correlation coefficient is denoted with rho, where rho equal to 1 minus 6 sigma d square divided by n into n square minus 1. So what is our question? The properties of rank correlation coefficient. So the properties of rank correlation coefficient is here minus 1 less than or equal to rho less than or equal to 1. The rank correlation, rho is nothing but rank correlation coefficient. The rank correlation coefficient is always lies between minus 1 and 1. The rank correlation coefficient is always lies between. The rank correlation coefficient is lies between minus 1 and 1. The rank correlation coefficient rho is lies between minus 1 and 1. That is minus 1 less than or equal to rho less than or equal to 1. Next question. Classify the lines of regression of x on y. So the lines of regression of x on y are regression lines of x on y is x minus x bar equal to byx into y minus y bar. X minus x bar equal to byx into y minus y bar, where x bar equal to summation xi by n and y bar equal to summation yi by n and bxy equal to summation x square divided by xy. So summation xy by summation y square. Okay, so this is the where capital X equal to x minus x bar, capital Y equal to y minus y bar. Next, state the form of regression lines of x on y. The regression line of x on y is, or the regression equation of x on y is x equal to a plus by. So we have to solve these equations, this one by using normal equations. So this is also called as the method of least square method. So next one is classify the lines of regression of x on y. Lines of regression of y on x, y on x. The lines of regression of y on x are the lines of the regression lines of y on x is y minus y bar equal to byx into x minus x bar. So where x bar equal to summation xi by n, y bar equal to summation yi by n and byx equal to summation capital xy by summation x square. So where x equal to x minus x bar and y equal to y minus y bar. And the next question is, what is positive correlation? If 0 less than r less than or equal to 1, 0 less than r less than or equal to 1, then it is called as positive correlation. So we know that r is always lies between minus 1 and 1. Okay. So what is positive correlation? The positive correlation is nothing but 0 less than r less than or equal to 1. Then it is called as positive correlation. So next one. So what is the negative correlation? If minus 1 less than or equal to r less than 0, then it is called as negative correlation. Because we know that r is always lies between minus 1 and 1. So if 0 less than r less than or equal to 1, then we can say that that is positive correlation. So if minus 1 less than or equal to r less than 0, then we can say that that is a negative correlation. Negative correlation. Next question. What is zero correlation? If r equal to 0, then we can say that that is zero correlation. If r equal to 0, then we can say that that is zero correlation, or there is no relation between the two variables. Zero correlation is nothing but there is no relation between the two variables or elements. Next one. State the formula regression. State the formula regression lines of y on x. The regression lines of y on x is capital Y equal to A plus Bx. So here we have to use the normal equations. The normal equations are here summation y equal to Na plus b into summation xy equal to a into summation x plus b into summation x square. So these are the normal equations. By using the normal equations, we can find the constants. After that, we have to substitute in regression line of y on x, that is y equal to a plus bx. So this is the formula for regression line of y on x or regression equation of y on x. And the last question is, state the definition of regression line. So regression line is a straight line which gives the relation between the variables or relation between two variables. Regression line is a straight line which gives the relation between two variables or two elements. So that is the definition of regression line. So this is our module 2, correlation and regression. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.